So we go to question 10 now. So question 10 reads, so a rectangular soccer field with a maximum possible area is to be designed inside an elliptical spot field given by the graph of x squared over 25 plus y squared over 9 is equal to 1. The length and width of the rectangular soccer field are 2x and 2y, respectively. So you have the length 2x and the width 2y. That is to be of the rectangular soccer field. That is to be designed inside an elliptical spot field. So the field, the soccer field will be inside an elliptical spot field. Given there, express the area of the rectangular soccer field. A bit of some disturbances, I think it's trying to misbehave. Okay, so we carry on. We'll start with expressing the area of the rectangular soccer field in terms of x. So what are we given? We are given x squared So question 10, we are given x squared over 25 plus y squared over 9 equal to 1. With the length 2x, width 2y. So now, the area of this rectangular soccer field will be given by the product of the length and the width, like that, which is 4xy. But maybe we can use the other equation given, the x squared over 25 plus y squared over 9 equal to 1, to get one of these variables in terms of the other. So if we went back and solved for y, we would say y squared over 9 is equal to 1 minus x squared over 25. And this guy is going to look like 25 and then 25 minus x squared. If we cross multiply by y, by 9, we're going to have y squared is equal to 25 minus x squared over 25, and then the whole thing by 9, which when we root it, we'll have y is equal to 3 over 5, and then the root of 25 minus x squared. So what I've done here is I've gotten, since I'm doing this, so you see, we know the square root of 9 is 3, the square root of 25 is 5. And then we leave root 25 minus x squared inside there. That will be our y. So when we come here, we're going to have area written as 4x, and where there's y, we put 3 over 5, and then the root of 25 minus x squared, like that. You see? like that. So this can be written as 12 over 5 x and then 25 minus x squared. And that is the part which says express the area of a rectangular soccer field in terms of x. This is the part A. So that is the area in terms of x. And then B, find the dimensions of the rectangular soccer field that will give the maximum area. Now to find the dimensions, that's where now we do the derivative. So we do dA dx. So we can actually write this as 12x over 5 multiplied by 25 minus x squared to the power half. So when we differentiate now, we're going to have 12 over 5, the root of 25 minus x squared using product rule plus 12 over 5x multiplied by half, and then we'll have 25 minus x squared to the power minus half, like that, which is going to be 12 over 5, the root of 25 minus x squared plus, so this 2 here, 1, 2 there, 6. So we get 6x over 5 multiplied by the root of 25 minus x squared. At this point, we equate this guy to 0. So when you equate it to 0, and then you multiply throughout by this. So we're going to have 12 multiplied by 25 minus x squared plus 6x equal to 0. Because as you multiply throughout this 5 and this 5, when you multiply throughout by, because I'm now multiplying throughout by what? By 5 root 25 minus. Okay. So that 5 and the 5 is down there, they will cancel, and then the root, they are cancelled, then the other part, the root, I remained on the inside. Okay. Oh, something I didn't do here is that I didn't differentiate this part. I was supposed to differentiate minus 2x. So here I could have minus 2x, so that this guy becomes a what? Becomes a minus. This guy becomes, what is it becoming of? It's becoming a minus 12x squared. Is it? Because here we did 4 over 5 multiplied by that plus 4x over 5. And then the root of that will give us a minus 2x. Yeah, and then the half makes that x and takes back. Okay, yeah. So we're going to get this as what? So if I can divide throughout by 12, our remain is 25 minus 2x squared is equal to 0. So that x squared is equal to 25 over 2. So we have x is equal to plus or minus 5 over root 2. As our x. But again, the negative one, we don't pay attention to it. So we're saying x is 5 over root 2. And then we go back to the dimensions. So since x is that, before we go back to the dimensions, we go to y. What should be our y? Y will be 3 over 5, the root of 25, minus, that will be 25 over 2. When we square the 5 over 2, giving us 3 over 5 root of 2 down, and then 50 minus 25. So that will be 3 over 5. 50 minus 25 is 25, and root 25 is 5 over root 2. So that is going to be 3 over root 2 as our y. So we're going to have the dimensions, length, which is 2x, which is equal to 10 over root 2. And also y, width, which is 2y, which is going to be 6 over root 2. So these will be the dimensions that are going to maximize the area of the rectangular soccer field. Any question? Okay, no questions. That was question 10. We can go to question 11. Question 11 says, find the equation of a tangent and normal to the following curves at the indicated points. Equation of the tangent and normal to the following curves at the indicated points. So the first one, so that is question 11. The first thing on record is that the equation of a normal line is going to look like y minus y naught equal to its gradient. Gradient, this is the tangent equation. So gradient of the tangent, and then x minus x naught. Of a normal is going to be y minus y naught equal to gradient of a normal x minus x naught. This will be a normal line. Okay. Now, in these two, we want to find these two equations of what? So we're given the first function f of x, that is part A. F of x is equal to x plus 2 over x at x is equal to 1. The first thing I do before I even start looking for that, I need to find a full point that I will call x naught, y naught. By getting this x, substitute it in the function so that I have 1 plus 2 over 1, which is equal to 1 plus 2, which is 3. So whatever I'm doing, the point is 1, 3. That is the given point. The question says at the given point, but we're only given the x value of the point. So we need to find the full point. So I get the x given, substitute in the function to get the y coordinate. Then from there, I'm now looking for the mt and the mn. The relationship between the two is I'm going to find the mt first, but then I know that the mt multiplied by the mn would actually give us -1. Okay, the mt divided by the mn should give us -1. So how do I get the mt? So I have got the mt function, which is the derivative of x of f, which is going to be 1 minus 2 over x squared. You see? So this guy is going to be mt when I substitute 1 where there is x. So I'll have 1 minus 2 over 1, which is -1. So this is the tangent gradient. And so to find the normal gradient, I'm going to say -1 over -1 using that. That is going to be +1. So now I'll have y minus y naught, which is 3, equal to mt, which is -1, x minus x naught, which is 1. And so we'll have y is equal to -x plus 1 plus 3, meaning y is equal to -x plus 4. This is the tangent line. Tangent line at 1, 3. The normal line will have everything similar apart from the gradient. So I'm going to get y equal to x minus 1 plus 3. That is y is equal to x plus 2. The normal line at 1, 3. Like that. You see? That's how we get those. Both the tangent and the normal line. That is for A. We go back to the question. We also have for B. Now, interesting is how the B function is. The B function is y squared over 4 minus x minus 1 squared over 5 equal to 1. At that point, you don't even know which one is your f of x. Okay? We don't know. But as usual, we'll do the implicit thing until we find the dy dx. So we go to B. So we have y squared over 4 minus x minus 1 squared over 5 equal to 1. At what point? For this one, we are given a full point. The 3 comma negative 6 over root 5. Like that. So now we differentiate this. So say 2y over 4 at dy dx minus 2x minus 1 multiplied by 1 over 5 equal to 0, because the derivative of 1 is 0. So now we substitute first we make dy dx a subject. So dy at dx is equal to 2x minus 1 over 5 multiplied by 4 over 2y. So when we substitute the given point in search of the empty, we are going to get 2, 3 minus 1 by 4 over 10 minus 6 over root 5. That is y there. And so this is a 2 here, 1, a 2 here, 5. And then that is 3 minus 1 is 2. By 4, that's 8. So we're going to have 8 over minus 30 over root 5, which you can write as 8 root 5 over minus 30. I think you can simplify a bit. 2 can go in both. Yeah, 2 can go. 2 can go in 8 4 times. 2 can go in 30 15 times. Like that. So that is the m tangent. And so let's find the m normal. The gradient of the normal is going to be negative 1 over 4 root 5 over minus 15, which is going to be 15 over 4 root 5. And then now we substitute. So the gradient of the tangent, so tangent line is going to be y minus, which will be plus 6 over root 5 equal to minus 4 root 5 over 15 x minus 3. And the normal, so you can simplify that. The normal line is going to be y again plus 6 root 5 equal to 15 over 4 root 5 x minus 3. So like that. That was on a lighter note. Question 11 was a bit light. Let's go to question 12. What does it say? Given the curve y is equal to x minus 1 to the power 3, and the line 3y plus x equal to 0, find the equation of all lines that are tangent to the curve and are also perpendicular to the to L. The given line. Okay. So we want to find, given the curve y and the line L, find the equation of all lines that are tangent to the curve and are also perpendicular to the line. That was that's question what? That's question 12. So what are we given? We are given y equal to x minus 1 to the power 3. We are given L, that will be 3y plus x equal to 0. So we can write this L to be y is equal to minus 1 over 3 x. So we take x other side, then divide by 3. So it will be like that. So the gradient of this line is minus 1 over 3. For n line perpendicular to that, remember it says we want to find lines tangent to y, perpendicular to the line. So n line perpendicular to that guy should have this relationship. That m, that their gradients should have the relationship. So let's call this ml, and the other one, the relationship should be -1. So now we have this m multiplied by this guy equal to -1. So meaning we are getting m equal to +3. So we want to find lines whose gradients. So all those lines, they'll have a gradient 3. Because n line with gradient 3 is perpendicular to the line L given. Now, how do you find the gradient of the line? We go to the y and differentiate it. dy dx gives us 3x minus 1 squared. That is the gradient equation. The first derivative is always referred to as the gradient equation. Of what? Of the tangent. So now we're going to equate this guy to the required, because we want them to have gradient 3. So we get the gradient equation and equate it to 3. So now we solve, we are going to have divide by 3, that will be x minus 1 squared equal to 1. So here we can do the root thing so that we get x minus 1 equal to plus or minus 1. And so we are going to have x minus 1 equal to 1, or x minus 1 equal to minus 1. So x is equal to 2, or x is equal to 0. So whenever I get x, I quickly rush back to y and substitute the 2. So I'll have 2 minus 1 power 3, giving us 1, or y 0 minus 1 power 3, giving so whatever has happened, I don't understand. Oosh. Yeah, so I think there's some disconnection. Everything has been lost. Yeah. Okay. Okay, so since the recording didn't stop, I think we were at a note where okay, I think something has happened. We need to cancel this.